Now in this example, you'll see three different aspects to our surface. You'll see these little pluses right here, which represent our point data. You'll see all of these lines connecting our point data, and those are what's known as tin lines. And then those tin lines are what create our surface contours. So let's dive into that a little bit more. Now the reason why we have so many points out here is mainly due to the fact that this looks like a mountain that was actually shot out here, and you can't necessarily get a field crew to shoot individual points with a rod, of course, on a mountain. So what they did is they probably used a drone with LiDAR, and what LiDAR does is it actually creates all of these points as it's flying over it. So you can get a drone to go out and go just back and forth across the site and collect all of these different points as it's flying around. In this example, all of our point data was entered in directly into the drawing as opposed to importing them with the survey database like we've done in the past. So all of these points are just housed within our drawing. If we click on our prospector, you'll see under surfaces we have an existing surface, and the surface is defined by a point text file that we brought into the drawing. So everything again is all housed within the drawing itself. So when we zoom in on our point data, you'll see that each point is connected to each other, and these lines are what they call tin lines. Now all of these tin lines create triangles between each of these point vertices. And in doing that, Civil 3D does what's known as interpolation. So the grade is calculated between each of these points, and that's what helps to develop our surface contours. In this example, again, we created our contours based upon point data that we inputted into the drawing, but you don't necessarily have to go that route. Instead, you can always bring in 2D or 3D polylines, and just so long as those lines have X, Y, and Z coordinate data, you can add them into your surface by clicking on Contours and clicking Add. Now there are two different types of boundaries. There are destructive and non-destructive. And what these boundaries are used for is to encapsulate our surface. So say for example, we don't want to include all of this triangulation in between these areas right here. So this could be, say, a lake, or it could be it could just be an area that we don't want to include maybe in our surface volume. So what a boundary will do is it won't include this triangulation. Now the difference between destructive and non-destructive is that if it's destructive, then it'll chop out all of these tin lines in between. But non-destructive, it'll include all of these tin lines. It just won't include them within, say, a volume calculation. We can also use the same concept to create an inner boundary as well. So we've got our outer boundary, and we can also have an inner boundary, say for a existing detention pond that we would like to, we can omit all of this information from our volumes. Lastly, I want to introduce you to the concept of breaklines. Now, say for example, there was an existing wall that was right along this area right here. Now, with a break line, We don't want triangulation to cross our wall. If our 10 lines cross our wall, it would create an inaccurate surface because it's not accounting for our wall itself. So say for example, if this was a retaining wall, a 3-foot retaining wall creates an obvious grade change, which our 10 lines are not accounting for. So break lines account for that. Now in this video, we're going to go through the process of creating a 10 surface in a brand new drawing. We do that by clicking on New, and then go ahead and go to your desktop and go to your Civil 3D Training shortcut. Brings you to your Civil Tutorials folder, and then click on the Surface Drawing Template. Go ahead and click Open. Now next, what we're going to do is we're going to create a surface by going up to the Home tab, and you see right here we have the Surfaces panel. We'll go ahead and click on that drop-down menu and then click Create Surface. Now next, you'll see in this dialog box here, we already have our type set to 10 surface, which is what we want. And we have our surface layer set to C-topo. Now note that by default, a new surface layer will be created named C-topo dash followed by the name you enter in the name cell, which we're going to go ahead and do that right now. We're going to type in EG for existing grade, and we're going to go ahead and give this a description. We're going to call this existing ground surface from imported point data. Now under style, rather than contours, let's switch this to points and border. Click OK. And then for render material, we're going to go ahead and leave this on bilayer. So after we've done that, go ahead and click OK. And now under the prospector and under surfaces, click the little plus icon, and now you'll see our created surface. But currently you'll see that under the definition, it's currently empty, meaning that the surface currently does not contain any data. So let's add point data to our surface. Go ahead and open our example file. And our examples are within a prepackaged copy of Civil 3D. Right here on my desktop, I actually have a shortcut to get to that folder. You can see where that's located right here. So go ahead and click on Civil Tutorials, Drawings, and we're going to browse for the Surface Tutorials. And I want Surface 1A. Go ahead and click Open. Click Yes to open in read-only. Now since this drawing is currently in read-only, I'd like to go ahead and save a copy to my desktop. Go ahead and click Save. Now, if you remember in previous examples, we imported survey data through the survey database. Now, the survey database is again a shared location to where if people are working on multiple drawings, they're able to pull that data. But in this particular example, we're going to import the point data directly into our drawing. So this data isn't being shared amongst other drawings. Now if we click on surfaces, we have an existing surface defined. However, if we look under definition, there isn't any data that's added to it. So let's go ahead and do that. Go ahead and click on the Modify tab and click Surface. And go ahead and click Add Data. What we have is an example text file that has all of our data that's comma delimited. go ahead and click Point Files. Click the little plus icon right here, and then our exercise file actually has this text file. Click Open. Scroll down until you get to the PNEZD option, and click OK. Now at face value it looked like nothing happened, but if we type in ZE for zoom extent, there it is. There is all of our data. And in fact, if we look under definition, we can see that data under point files, which is listed below. So that's how you add point data to a surface in Civil 3D. Alright guys, in this video we are going to display the source polylines and change the surface style. Now note, this exercise uses the drawing you created in the previous exercises. Or you can open the Surface 1B drawing by clicking Open, Drawing. Click on your Civil 3D training shortcut, Civil Tutorials, Drawings, and scroll down till you get to Surface 1B. Now click on the Home tab, go to your Layers panel, click on the drop down, and navigate to the _EG_breaklines layer, which can be found up here. Let's go ahead and thaw that layer. Click on it, and you can see how our polylines showed up right here. Now the 3D polylines, let's go ahead and select them. These 3D polylines represent the edge of pavement of an existing road that are displayed on the east side of the site. Note that the edge of pavement polylines were included in the drawing template you used in exercise 1, creating a tin surface. Let's go ahead and exit out of this, deselect our polylines. Now select the surface and then right click. Click Surface Properties. And now in the Surface Properties dialog box, we want to look at the Information tab. And under Surface Styles, we want to click on Contours and Triangles because we want to see our tin lines. Now click OK. There's a lot going on there, isn't there? Now the surface now shows contours and triangles that illustrate the existing surface triangulation. Now let's create break lines from the 3D polylines. In the tool space under our Prospector tab, which we're already in, I want you to go under Surfaces, click that little plus icon, and you see right now for our existing surface we have this little circle with a slash through it. Right now it says that this surface is locked in the drawing. Let's right click our surface and click Unlock. Next, go to the plus icon and click our definitions, and right here we have a definition for break lines. Go ahead and right click on that, click Add, and then we get our Add Break Lines dialog box here. Under Description, type in edge of pavement dash existing road. And then we're going to use the default values for the rest of this stuff right here. Next, go ahead and click OK. Now you see how right now next to our cursor and in our command line it says select objects. So let's go ahead and do that. Let's select our edge of pavement and hit enter. Now the surface triangulation is now modified, as you can see. The edge of pavement and break lines are applied, and the tin surface is adjusted along the break line edge. So we just modified the surface triangulation. So that's how you add break lines to a surface in Civil 3D 2020. Because surfaces can contain large amounts of data, it's important to use only as much data as necessary for the current task. For example, when building a surface from LiDAR data, the corresponding point file can contain millions of points, as you can see in this example. If all of these points are included in the surface definition, it can take a considerable amount of time to rebuild the surface. However, if you restrict the points that the surface uses to a given area, the surface rebuilds a lot faster, and the drawing size is smaller. Okay, so go ahead and go over to the big C, click Open, browse to your Civil 3D training shortcut, click Civil Tutorials, and go to Drawings. Next, scroll down to the Surface-2 drawing. Now in the Tool Space panel, go to the Prospector tab, expand the surfaces, and expand the existing surface. Now you'll see under the definition that the surface is currently empty. In the following steps, you'll use this red polyline in the drawing to create a data clip boundary, which will restrict imported surface data to the extents of this boundary. Then you'll import a relatively dense LiDAR point file and examine the results. So go ahead and expand the existing surface definition, right-click on Boundaries, and then click Add. Now in the Add Boundaries dialog box, specify under Name, let's go ahead and put Site. Under the Type drop-down, we want to click Data Clip, and the mid-ordinate distance, we'll keep that at 1. Go ahead and click OK. Now in the drawing window, click the red polyline. Let's zoom in a little bit here. Click it just like that. Now the polyline is added to the existing surface definition as a boundary. The presence of a boundary in the surface definition is indicated by the marker next to the boundaries. You'll see this little black box right here. Now when the boundaries collection is selected, the boundaries that have been added to the surface appear in the Prospector tab. Next, in the following steps, you'll add a relatively dense LiDAR point file to the surface definition. Now the point file will be added only within the extents of the data clip boundary that you just added. So let's get started with that. Go ahead and expand the existing surface definition collection like we did before. Right-click Point Files, click Add. Now in the Add Point File dialog box, go ahead and hit this plus icon right here. Now in the Select Source File dialog box, be sure that you set the file type to CSV, which is a comma delimited file, and go ahead and select LiDAR_ENZ. And this file can be found under the Civil Tutorials folder. Click Open. Now in the Format list, select the ENZ, meaning easting, northing, and point elevation. Now in this instance, uncheck the Do Elevation Adjustment if possible. Go ahead and click OK. Now the point data is added to the drawing. A reference to the point file is listed right here, and the presence of the point data is shown by this little black box right here. Now zoom in to the right corner of the surface. Now when we zoom in, you'll see that imported data is actually triangulating outside of our data clip boundary. Now let's try something different. Click on the Home tab and go to your layers. Go ahead and thaw this layer, C-topo-boundary-corridor. You can see a brand new boundary just showed up. Now let's go through the same process that we went through before when it came to adding a boundary. Right-click on Boundaries, click Add. This time in the Add Boundaries dialog box, type in the following: corridor, keep the type on data clip, and keep the default mid-ordinate distance. Click OK, and select our line. Now you'll see in the drawing window it looks like nothing really happened. You'll see that there's an orange polyline and an instance of our brand new boundary, but nothing's changed. That's because the points were added to the surface before the corridor boundary. The boundary currently does not affect the point data, but in the following steps you'll arrange the surface definition operations so that the points will be restricted to the extents of the new corridor data clip boundary. In Toolspace on the Prospector tab, right-click on the existing surface and click Surface Properties. Now in this dialog box, go to Definition. Now under Operation Type, you can see the order that we have going on here. The operations you perform in this exercise are listed in the order in which they were performed. The site data clip boundary was added first, which is listed right here, and it affects the operations that follow it. The corridor data clip boundary was added last, which you can see right here, so it currently doesn't affect any other operations. Select this last boundary and add it to the top of the list. Next, select the other Add Boundary and bring that to the bottom. Now click OK. Go ahead and click to rebuild the surface, and there you have it. When the surface rebuilds, the points outside of the orange corridor data clip boundary are excluded from the surface. So that's how data clip boundaries work in Civil 3D. So I'm currently in drawing 1B, which is a continuation from our tutorial based upon how to import break lines. But now we're going to create an outer boundary from a polyline. So first, go ahead and go to your Home tab, then go to your Layers, scroll up until you get to underscore existing boundary. Go ahead and thaw that boundary. And what you'll see is we have this blue outer polyline that surrounds our entire site. Now this blue polyline represents the extents of the site. The polyline was imported with the original surface contours. But go ahead and go into your tool space, and under Prospector, I want you to go under Surfaces, click the little plus icon, click it again underneath the existing grade. Go to your surface definition collection, expand that out. Next, I want you to go to Boundaries, right click on Boundaries and click Add. We'll get our little dialog box right here for Add Boundaries. Next, I want you to type in EG space dash outer. We're going to keep our boundary type as outer. Clear out this checkbox for non-destructive break line, because we don't want to do that in this instance, and keep the default mid-ordinate distance of 1. Click OK. Next, it's going to ask you to select that blue polyline. Go ahead and zoom in to an area right here. And when we zoom out, you can see that this blue outer boundary has clipped out a lot of the other information that was there before. Next, I want you to hide this blue polyline. We go back under Home, go to our Layers panel, scroll up until we get to underscore existing grade dash boundary again. Go ahead and click the freeze icon, and now that blue polyline will disappear. Next, go ahead and select your surface, right click on the surface, select Surface Properties, And now under the Information tab, I want you to change the surface style to Contours 5-foot and 25-foot background. Click OK. And now you can kind of see a ghosted in surface right here where contours are displayed as muted colors at broad intervals. This display allows major surface features to remain visible while you focus on other aspects of the site design. In this exercise, you will use the point removal method of simplifying a surface. This method randomly selects points from the surface and reduces them based on the point density at different areas of the surface. More points are removed from areas in which the concentration of points is very dense than from areas that contain fewer points. Now note, you can't specify which points to remove. Points that are used to define surface borders and break lines are not removed with the Simplify Surface command. Note that this exercise is a continuation with the use of the Surface-2 drawing. So let's continue. Go ahead and click on the Home tab. Go to your Layers panel and browse till you get to the C-Topo-Contour Major Original. Let's use this little scroll bar right here. This might work a little bit faster. There we go. We've got a couple of these layers that need to be thawed. Select that and select that. Go ahead and click out of your Layers panel. So here are our contours. Now these layers, they contain polylines that represent the original major and minor contours. These polylines will enable you to observe the results of the Simplify Surface command. So go ahead and click on the Modify tab. Click on the Surface. And next, go ahead and go to the Edit Surface pull down and go to Simplify Surface. Now this wizard gives you a few options. What I want you to do is click on the Point Removal. Click Next. And then I want you to select Objects. And see right now the total points selected in region is currently at 0. Let's change that by picking our objects in the drawing. Now the object that I want you to pick is the orange corridor boundary. Note that we have all of these points that are selected within that region. That's quite a bit, wouldn't you say? Alright, the next thing that we're going to do is go ahead and click Next. And we're going to cut the amount of points that we have in this region in half. Let's go ahead and clear out the maximum change in elevation. We're not going to be focused on that for right now. Now the next thing to do is go ahead and click Apply. See what happened? The total points removed was about half of the original number. Now note that you can click Apply again to repeat the Simplify Surface command and keep the wizard open. If you click Finish, the Simplify Surface command is repeated and the wizard is closed. Let's go ahead and click Cancel. Now currently, the amount of points in this area, which you can faintly see in blue, is not as dense as it was before. Now the new gray surface contours that we have right here, they match our original polylines fairly close to what we originally had. You can see the little deviations that we have right here. Now the Simplify Surface command can reduce the amount of data that the surface uses without sacrificing much of the surface accuracy. The upcoming tutorials will demonstrate how to change and constrain the surface styles and display. Using styles is an efficient way to control surface display. Rather than answering prompts for numerous variables every time you create a surface, you can reference a predefined style that sets all of the variables as required. Surface styles are managed the way all object styles are managed in Civil 3D by using the Toolspace settings tree. All objects have a standard object style grouping on this settings tree called the object style collection. You can create, edit, copy, and delete the styles for an object. Surface styles define how the surface components are displayed in the drawing. If you want to change the appearance of a component, either apply a different style or edit the style. The surface styles contain the following component parameters and component display settings for the creation of surface data objects, such as borders, contours, grid, points, triangles, watersheds, and analysis. So let's edit the surface style. Go ahead and open your Surface-3 drawing in your tutorial drawings folder. And then what I need you to do is I need you to go under Settings within your tool space. And right now you'll see up at the top that we have the Active Drawing Settings view. If you click on that, we've got a lot of different options right here, but I want you to stick to this one right here. Next, go underneath Surface and pick the drop-down menu for Surface Styles. Go ahead and right-click on Standard, click Edit, and then we get our Surface Style dialog box. What I need you to do next is click on the Display tab, and currently we have all of these red tick marks for our points. I'd like to go ahead and turn those off. So I click off the visibility, click Apply, so we see those changes take effect. Then go to Contours. And you'll see right here we have an option under Properties for Contour Depressions. This will give us some options here, and it gives us the option to display depression contours. Right now it's currently set to false. Let's make that true. Now for the tick mark interval, I'm going to leave that at 50, but the tick mark length, I'm going to turn that into 5 feet. What I want to do is show tick marks along the entire length of each one of these depression contours. So I'll go ahead and click Apply, and then click OK. So if I zoom in here, you'll see all of these tick marks are every 50 feet, and the length of each one is about 5 feet. And they all go along the length of the entire depression contour. So let's go ahead and change the surface style. Now note that this exercise uses the Surface-3 drawing with the modifications you made from the previous exercise. In the tool space under the Prospector tab, go ahead and maximize our surface collection, and then click on our existing surface, right click, and click Surface Properties. Next, let's go ahead and change the surface style. We're going to change it from standard to borders, triangles, and points. Go ahead and click Apply, and we can see how this surface is constructed with all of the tin lines. Okay? Now this style is set to display the borders and the tin faces with 3 times the vertical exaggeration. These display settings make it a lot easier to see the vertical relief on the surface. So go ahead and click OK. The surface representation updates to display the tin triangles and the border. So let's see how this looks in 3D. Click the View tab and click the Free Orbit drop down. Click Free Orbit, and as you drag, you can see this vertical exaggeration. Now using the Free Orbit tool, rotate the surface in the drawing to display the exaggerated elevations. These elevations are most evident along the bottom of the surface where the prominent ridge appears. To return to the regular plan view of the surface, go ahead and go back to the View tab, click this drop-down menu, and click Top. Now to return to the original surface style, go ahead and right-click on the surface, Surface Properties, and change the style back to standard. Click Apply, and we're right back to where we were. In this exercise, you'll add labels across surface contours. You will place individual labels manually and a series of labels automatically, using the AutoCAD polylines as a guide. Note that this exercise uses the Surface-3 drawing with the modifications you made from the previous exercise. Let's start by clicking on the View tab. Now in the Name Views panel, go ahead and click this drop-down menu and click on Surface Labels. See how we have 3 different circles right here? We're going to use these as a reference. On the command line, go ahead and type in PL for polyline and click the center of the first circle, the circle of the second, and then the third. What we're going to do is we're going to use this polyline as a guide for our labels. Next, go up to the Annotate tab and click on the Add Labels. We'll get this little Add Labels dialog box right here. And then click on the drop-down menu, click Surface, and then for label type, rather than slope, let's select Contour Multiple. Because by doing this, this will automatically add multiple labels to our contours. We'll go ahead and leave all of our defaults and click Add. Notice down at the bottom in our command line, it's asking us to specify the first point or objects. What we want to do is we want to select objects and select our polyline. So go ahead and click on objects, or you can type in O and then press enter. Next, the command line asks us if we want to erase the original entities, meaning do we want to delete our guideline. I'm going to go ahead and click yes. Go ahead and zoom in and select the polyline. Press enter, and there you have it. All of our contour labels are now shown along our guide. This method of surface labeling is useful when you want to lay out the path of surface contour labels before you actually create the labels. But what if I wanted to create the path and labels simultaneously without first drawing a polyline? Let's go ahead and do that. Go back into your Add Labels dialog box right here. Let's go ahead and erase what we created originally. And then go ahead and click Add. Instead of selecting objects, we're going to specify the first point, which would be the center of the first circle, then the second, then the third. So essentially it accomplishes the same thing. But what about spot elevations? How do we go about showing that on our surface? We'll go back into our dialog box right here. We want to stay on surface. We want to change our label type to spot elevation. For right now, let's keep the defaults for spot elevation style and marker style. Go ahead and click Add, and just pick a point right here along the ridge. Next, it asks us for another point. Instead, I'd like to change the elevation label style to something different. Let's change it to foot meter. Go ahead and click along the ridge again, and then we get a totally different spot elevation style. So that's how you label a surface in Civil 3D. Edge swapping is used to change the direction of two triangle faces in the surface to create more of an accurate surface model. For example, edges can be swapped to match the triangle edges to ridges or swales. So right now I'm in the Surface-4A drawing, which is located in the Tutorial Drawings folder. And in this drawing, the surface is displayed as 10 lines. in red right here, and it's overlaid with an externally referenced land-based image. So what we're going to do first is we're going to zoom in to the lower edge of the surface, right around here. Now in the tool space within the Prospector tab, go ahead and expand the surface. Go down to Edits, right click, and click Swap Edge. So right now Civil 3D is asking us to select an edge. So let's go ahead and zoom into an area right here, and let's swap this edge and this edge. Let's try swapping some other edges. We can go through here. We can do that, but that would break this little edge that we have for our ridge. So let's go ahead and swap that back. How about over here? We could do, no, it won't allow us to select that edge. So that edge can't be swapped. Let's try another one. Here, or here, here, or over here. So optionally, you can continue to click other 10 edges to swap them. But once you're finished, go ahead and hit Enter to end the command. Now you'll see that the edits are added as swap edge operations to the Edits list view on the Prospector tab. Now note that the description column in the list view provides the coordinates of the pick point along the edge that was swapped. Deleting 10 lines may be required, for example, if the surface has 10 triangles on the perimeter that are long and narrow. In this case, the triangles might not be accurate for the surface and should be deleted. Surface tin or grid lines can also be deleted within a pond, for example, to create a void area. By removing these lines, you can prevent contours from being drawn through these void areas. When an edge is removed, either an interior border that follows the adjacent lines is created, or an exterior border is modified to follow the new lines. In this exercise, you'll delete 10 lines from a surface. The 10 lines that fall within a pond, we're going to remove these lines, and by removing these lines, you can prevent contours from being drawn through the pond area. This exercise continues from the swapping 10 edges exercise. Go ahead and open up your Surface-4B drawing, which is located in your Tutorials folder. In this drawing, the surface is displayed as 10 lines that are overlaid on an externally referenced land-based image. Zoom into the rounded pond area in the upper left of the surface. In the tool space on the Prospector tab, go ahead and expand the surface. Now right-click on the Edits collection. Select Delete Line. Now on the command line, you're now prompted to select an edge to remove. Click these edges that cross the surface of the pond. And then press Enter. The edge is removed and an interior boundary is created following the adjacent 10 lines. The edits are added as delete operations to the Edits list view in the Prospector. The description column in the list view provides the coordinates of the vertices for the edge that was deleted. So that's how you delete 10 lines in Civil 3D. Hide boundaries mask areas of the surface so triangulation and therefore contours are not visible in the area. Use hide boundaries to create holes in a surface, for example, to mark a building footprint. When you use a hide boundary, the surface is not deleted. The full surface remains intact. If there is a surface tin line that you want permanently removed from the surface, use the delete line command. In this exercise, you'll create a hide boundary on the surface which will mask unwanted triangulation. A boundary can be created from any polygon or polyline, but in this exercise you'll use an existing break line. This exercise continues from deleting tin lines. So let's get started. Open up the Surface-4C drawing located in the Tutorial Drawings folder. In the tool space, go ahead and expand your surface, and then under the definition collection, go underneath boundaries, right click on boundaries, and select add. Now go ahead and type in the following parameters: xgnd-pond space hide. Change the type from outer to a hide boundary, and we want to keep the non-destructive break line option checked and the mid-ordinate distance at 1. Go ahead and click OK. In the drawing, go ahead and zoom in to our pond and then select the blue line. Hit enter, and now the hide boundary is added to the surface definition. The surface displayed in the drawing is modified to display the pond as a hole in the surface. So that's how you add a hide boundary in Civil 3D. Surface smoothing is an operation that adds points at system-determined elevations using natural neighbor interpolation. The result is smooth contours with no overlap. You perform smoothing as an edit operation on a surface. You can specify smoothing properties and then turn them on or off. When the smoothing is turned off, the surface reverts back to its original state. However, the smoothing operation remains in the surface operation list and it can be turned on again. Natural neighbor interpolation is a method used to estimate the elevation of an arbitrary point from its set points with known elevations. This method uses information in the triangulation of the best known points to compute a weighted average of the elevations at the natural neighbors of a point. To use natural neighbor interpolation, specify only the output locations of the interpolated points. The elevations of the interpolated points are always based on the weighted average of the elevations of the existing neighboring points. Natural neighbor interpolation interpolates only within the surface. In this exercise, you will smooth a surface using the natural neighbor interpolation method. This exercise continues from the adding a hide boundary exercise, so let's begin. Open the Surface-4D drawing, which is located in the Tutorial Drawings folder, and in the tool space in the Prospector tab, go ahead and expand your surfaces. Next, go under Edits and right-click. Choose Smooth Surface. Now in this dialog box, we're going to keep the defaults for the smoothing method and our output locations. The grid-based output location interpolates surface points on a grid defined within specified polygon areas selected in the drawing. After the areas are defined, you can specify the grid X and Y spacing and orientation properties. For the select output region, go ahead and click on these three dots. Next, the command line is asking for a region or these three different options. Go ahead and enter in surface. In the Smooth Surface dialog box, go ahead and enter in the following. For X grid spacing, type in 10. For Y, enter in 10 as well. Now in the drawing window, notice that there are contour lines that are especially angular. Go ahead and click OK to smooth the surface. Now you see the display of the surface is now smooth and contours are less angular. A smooth surface item is added to the edits list, as you can see right here. And you can see under description we use natural neighbor smoothing. You can delete the smooth surface edit from the list if you want to. Go ahead and select delete. Press OK. Go ahead and rebuild the surface, and it goes right back to the original surface configuration. Now you can also reverse the smoothing operation by pressing the undo command, which is U. And it goes right back to surface smoothing. So that's how you go about smoothing a surface in Civil 3D. This tutorial demonstrates how to create two kinds of surface analysis, watershed and water drop. You use watershed analysis, which is one of the several types of analysis that you can perform on a surface to visualize and analyze the surface watersheds. You use water drop analysis, which is a separate utility, to trace the path that water would take across a surface. Autodesk Civil 3D uses tin lines to calculate the areas that water would flow along the surface. From these areas, the drain targets and watersheds are determined. Other types of surface analysis include slope, aspect, elevations, and contours. Hey everybody, welcome back to the channel. In this tutorial, we'll be configuring a style for watershed display in Civil 3D. So let's get started. In this exercise, you will configure a style for watershed display. Go ahead and open up your Surface-5A drawing in your Tutorials folder. Go ahead and go over to your tool space and click on the Settings tab. Look over to your surface and expand that. Expand the surface styles. Right-click on Standard and click Copy. So we get our surface style dialog box here. Go to your Information tab and enter Watersheds. On the Watersheds tab, go ahead and expand the Depression Watershed group. Change the hatching to True. Now let's go ahead and change the hatch pattern. We're going to select Sand. Click OK. The scale we're going to go with is 15. Click OK. Now go to your Display tab. Now under the Component Type column, we have Watersheds. Go ahead and turn that on. Click OK. Next, go into your Prospector and then expand your surfaces. Right-click on your surface and select Surface Properties. Now right now the surface style is set to Standard. Let's change that to Watersheds. Click OK. And all of our watershed information is now included with this style. So that's how you configure a style for watershed display in Civil 3D. In this exercise, you'll generate and display the watershed analysis. This exercise uses the Surface-5A drawing in your Tutorials folder. So let's get started. In the tool space, go ahead and navigate to your surface in the Prospector. Right-click on your surface and select Surface Properties. Now go ahead and choose your surface style. Let's select Watersheds. After that, go up to the Analysis tab, and for the type, select Watersheds. Now ensure that Standard is selected in the Legends list. Next, you see this little downward arrow right here? Go ahead and select that. Now our watershed analysis has been developed. Next, click this light bulb off to the far right. Now next to boundary point and boundary segment, we want to turn off these watershed types. Click OK once, and then click OK the second time. Now go ahead into your surfaces and expand those out. Click on your watersheds, and then you get a tabulated list of all of our watershed areas right here. And what it does is it fixes an ID and a particular type of watershed. So for example, as we scroll down here, we have boundary point, boundary segment, and then it gets into depression. And it also lists where this watershed drains to. So go ahead and select 112, right click, and select Zoom to. And this will take us right to our watershed area. And it shows us where this is draining to. We select 130, zoom to that, then it shows us the catch basin that it's draining to. So that's how you go about generating a watershed analysis in Civil 3D. This exercise continues from the modifications you made from the last exercise in Surface 5A. So let's get started. Go ahead into your tool space and click on the Settings tab. Now you'll notice that we have some other types of styles within our surface style. Click on and maximize the table styles and maximize the watershed. Then go ahead and right click on Standard and select Edit. Now we're in the Table Style dialog box. Go ahead and click on the Data Properties tab. Now if it isn't already, you have to make sure that the Sort Data is cleared out and unchecked. Then click OK. Next, go under the Annotate tab, select the Add Tables button, and click Add Surface Legend Table. Next, we have some prompts down here in the command line. Go ahead and select Watersheds. Next, you're prompted to specify whether you want the table to be automatically updated if the analysis information changes. Go ahead and enter Dynamic, because we do want to enable automatic updating. So now if a change is made to the surface and the watershed analysis is regenerated, the legend is automatically updated. Next, it's asking us to click a location in the drawing where you want the upper left corner of the table. I want the legend table to be displayed over here. So now you'll see what we've got going on here. So that's how you go about creating a watershed legend in Civil 3D. In this exercise, you'll use watershed data to create non-destructive AutoCAD objects from the surface. So let's get started. This exercise uses the Surface-5B drawing with the modifications you made in the previous exercise. But in this drawing, what we need to do first is we need to bring back our watersheds. So go ahead and right click on your surface, click Surface Properties, then choose Analysis. Bring up the analysis type, which is watersheds. Click on the downward arrow to run the analysis, then click OK. So when we go to select our watershed, you'll notice that it's still tied to the surface object. But what we want to do is we want to extract that information from our tin surface object. First, we need to select our surface, which brings up our contextual menu. And then if you look under Surface Tools, there's an Extract from Surface button. Go ahead and click that drop down and click on Extract Objects. Now in the Extract Objects from Surface dialog box, we want to uncheck everything except for watersheds. Go ahead and click OK, and go ahead and escape from the command to deselect your surface. Now what you'll see is that if we click on our watershed, now it's created AutoCAD objects from each of the watersheds within the drawing. So that's how you go about extracting objects from a surface in Civil 3D. In this exercise, you'll create lines that illustrate the path that flowing water would take across a surface. Then you'll create a polygon that defines the catchment region and its area on the surface. Go ahead and open up your Surface-5C drawing in your Tutorials folder. Next, go into your Analyze tab and choose the Flow Paths drop-down. Click Water Drop, and then we get the Water Drop dialog box. Now in this box, go ahead and specify the following parameters. The path layer, we're going to change that. Click this button right here and choose this layer. Click OK. We're going to leave the path object type at 2D polyline, and then we're going to place a marker at the start point. We're going to leave that at yes, and then the start point marker style, we're going to leave that at WD start. Click OK. Now in the drawing, go ahead and zoom in to this area and click several locations in this area. A 2D polyline is drawn representing the flow of water from the spot you selected. Now the start point is represented by these markers right here. Let's go ahead and create a few more paths. Let's continue up here, up here, up here. You can start to see how the water path splits as you create additional lines. Go ahead and press Enter to end the command. Now if you notice that most of the water drop paths drain to these existing culverts. Next, you'll use the water drop paths you just created to define a catchment area that influences these culverts. Now we do that by going back into our Analyze tab and click on the Catchment drop-down and click Catchment Area. Now we're looking at our Catchment dialog box. Let's make the following changes. We're going to keep the display discharge point at yes, but we're going to change the discharge point, and we're going to choose Catchment. Click OK. We're going to change the layer to See Topo Catch. Click OK. And we're going to leave it at a 2D polyline. Then click OK. Now in the drawing, go ahead and begin to click on each one of our markers. Now note, if you receive a message indicating that the specified location results in a catchment area with no area, it means that there is no flat area or high spot on the specified point. Now we can go about combining multiple catchment areas, because we do have a lot going on in here. So let's go about combining multiple catchment areas. In the drawing, go ahead and isolate your catchment areas. Go ahead and select your polygons. Now in the command line, type in line work shrink wrap. A polygon that contains the combined area of the catchment areas is displayed, The linework shrink wrap command creates a single outside boundary of a selection of touching polygons. The original polygons are not deleted. Now this is a tip that you can transfer individual or shrink-wrapped catchment area polygons to a hydrology application for further analysis. So that's how you go about analyzing surface water runoff in Civil 3D.